I'm Monica Grady. I'm Professor of Planetary and Space Sciences at the Open University. We are part, obviously, of the solar system. People know about the Earth and all the other planets. Between Mars and Jupiter is the asteroid belt. And although most of the asteroids are in safe orbits and stable orbits, sometimes they collide with each other and knock bits off, and they fall to Earth as meteorites. And it's these meteorites that I study. Sometimes they come as tiny, tiny, tiny little dust grains, no bigger than a grain of sand. And you can't imagine that doing any damage. Sometimes, though, they're enormous, great, big things, which can really, really hurt, especially if they fell on your foot. So I've been talking about all the different effects you would get. A dust grain can do a lot of damage because they're travelling very fast, and imagine it hitting the windscreen or whatever is at the front of the International Space Station. Make a huge hole and then everybody would die. So you might think dust grain, no problem, but it all depends where the meteorite falls. The great thing about studying meteorites and also asteroids is that we're building up a lot of knowledge about the physical properties, how hard they are, how dense, how often they fall, how often the really big ones fall. And this is important because we live in this, we're a target Earth for all these impacts. And there have been big collaborations between astronomers and planetary scientists using telescopes to observe asteroids and chart all their orbits and get a statistical view of how many asteroids are going to come close to the Earth and what the chances of the Earth being hit by a big asteroid is. And of course, the more we know, the more of these asteroids we see. And it's a bit frightening when you think how much is sort of charging around out there. What might keep you awake at night is the fact that it's not if the Earth is hit by a big asteroid. It's when is the Earth going to be hit by a big asteroid, because it is going to be hit by a big asteroid. It's been hit by huge asteroids in the past, one 65 million years ago when all the dinosaurs were wiped out. And that was good for us because that allowed the mammals to evolve and dominate the surface of the Earth. Many, many billions of years before that, the moon was formed in a giant collision. These giant collisions happen, they don't happen very often. They happen about every 50 million years. The dinosaurs were killed 65 million years ago, and we haven't had a big collision since then. So you might argue we're actually 15 million years overdue for the big one. The study of meteorites is really important because it helps us understand the Earth, it helps us understand our own environment. Meteorites are the building blocks from which the Earth and all the other planets formed. They formed at the same time as the Sun from the same swirling cloud of gas and dust. And we can look at meteorites and get an idea of the primitive material that made the solar system. We can understand more about the Earth, about the core of the Earth, by studying metal asteroids, about volcanic processes, by studying meteorites that have come from volcanic asteroids. And all these things link together in helping us to understand how the climate has been affected by meteorite impacts. Meteorites tell us about the original material that made the Sun and the planets, including the Earth. So they're the building blocks from which the Earth was made. And the Earth has changed over 4.5 billion years. We haven't got any of that original material left. So if we want to know about the original stuff, we have to study meteorites. There are different types of meteorites. Some of them are made of metal, and they are really close to what we think is at the core of the Earth, which we can't access in any other way than by studying meteorites. So it's important to study them if we want to understand the planet. It's also important to study them because they can lead you on to other things. They can lead you on to understand the moon, to understand Mars and processes on Mars. If we want to look at, say for instance, going to the moon or travelling to Mars, we need to understand how the meteorites have come from Mars or come from the moon, all these sort of things. It fills out the picture of the solar system. And they're really interesting in their own right, you know. So if you want to imagine somebody, you know, thinking, oh, well, what's up there, you know, in the stars, and you can hold a bit of a star in your hand in a meteorite, because they've got grains that have come from supernovae in them, grains that have come from lots and lots of different types of stars. They're embedded in these meteorites. So you're holding something which is from the dawn of the solar system and contains grains from other stars in it. And that's something which is quite inspirational to young people, to try and get them to understand science and engineering, and hey, we need to build some more space missions to go to comets and to go to asteroids and bring rocks back from Mars. And you can use studying meteorites to really bring out that excitement.